Good morning, everyone, and thank you for being here today. We're going to dive into the fascinating world of forensic science, focusing specifically on the analysis of hairs and fibers. Throughout this presentation, we'll explore the various techniques used in forensic labs, how to interpret the findings, and their crucial applications in solving criminal investigations. I'm excited to share this with you and uncover the vital role these tiny pieces of evidence play in justice. Let's get started. Hairs and fibers play a crucial role in forensic science as key types of trace evidence. They have the unique ability to connect suspects or victims to crime scenes by showing that physical contact occurred. This transfer can happen in different ways, either directly or indirectly, and analyzing these traces can reveal important details about how a crime happened. Because hairs and fibers are durable and easily transferred, they're commonly found at crime scenes. Their presence often provides vital clues that help investigators piece together what took place, making them indispensable in solving criminal cases. When we compare human hair to animal hair, there are a few key differences to keep in mind. Human hair usually has a consistent pattern in the cuticle scales, which are the outer layer of the hair shaft. The medulla, or the central part of the hair, can vary in thickness, but tends to be less prominent than in animal hair. Also, human hair falls within a certain diameter range, generally thinner than many animal hairs. On the other hand, animal hair stands out because of its unique medulla patterns, which can be quite distinct and varied. The scale structures on animal hair are also different, often more irregular or pronounced. Additionally, animal hair often has a larger diameter than human hair, which can make it easier to distinguish under microscopic examination. These differences are crucial for forensic analysis and other scientific studies where identifying hair origin is important. When we talk about fibers, the main way to classify them is by their origin. First, we have natural fibers, which come directly from plants or animals. Common examples include cotton, which comes from cotton plants, wool from sheep, and silk produced by silkworms. These fibers have been used for centuries due to their comfort and breathability. Next, there are synthetic fibers, which are entirely man-made through chemical processes. Fibers like nylon, polyester, and acrylic fall into this category and are prized for their durability and resistance to wrinkles and shrinking. Finally, semi-synthetic fibers are a hybrid of sorts. They start with natural materials but undergo chemical modification. Rayon is a prime example. It's made by processing cellulose from a pulp to create a fiber that behaves somewhat like natural fibers, but with added versatility. Understanding these categories helps us appreciate the diverse qualities each type of fiber brings to textiles. When collecting evidence, it's crucial to use clean tools like tweezers, tape lifts, or vacuum devices. This helps us gather samples precisely without contaminating them. Next, proper packaging plays a big role in preserving the integrity of the evidence. Using breathable containers such as paper envelopes or bags prevents the samples from degrading over time. Finally, documenting the location and context of each sample right at the crime scene is essential. This detailed record ensures we understand exactly where and how the evidence was found, which is key for accurate analysis later on. Microscopic examination plays a vital role in hair and fiber analysis, serving as a foundational tool in forensic investigations. Using light microscopy, we can observe important characteristics like color, shape, texture, and scale patterns on hairs or fibers, which helps us understand their unique features. Another powerful technique is comparison microscopy, which allows us to examine two samples side by side. This makes it easier to spot similarities or differences, providing strong evidence in linking materials to specific sources. Together, these methods give us detailed structural information that's crucial for identifying the origin of the evidence and connecting it to individuals or environments. When it comes to advanced forensic techniques, one of the most powerful tools we have is DNA analysis. By examining hair roots, we can genetically identify individuals with a high degree of precision, which is invaluable in linking suspects or victims to a crime scene. Another critical method is chemical analysis, where techniques like spectroscopy and chromatography allow us to break down fibers to understand their exact composition and the dyes used. This detailed characterization helps differentiate materials that might otherwise seem identical. Together, These approaches significantly improve the accuracy and specificity of forensic conclusions, making the evidence stronger and more reliable throughout the investigative process. When forensic specialists analyze hair and fiber evidence, they look closely at several factors. They consider the presence, the number, and the specific types of hairs or fibers, comparing these findings carefully to reference samples. This helps them understand whether the evidence is significant. They also remain cautious about the possibility that hairs or fibers might have been transferred accidentally or contaminated, which could affect the reliability of the results. Importantly, their interpretation is always done in the context of the investigation, meaning they consider how these findings fit into the overall case scenario. Ultimately, accurate interpretation is crucial because it helps establish important connections between suspects, victims, and crime scenes, which can heavily influence the direction of the case and the decisions made in court. In forensic investigations, hair and fiber analysis can be incredibly powerful tools. For example, unique fiber matches found on a suspect's clothing can directly link them to a crime scene, offering key evidence that supports the investigation. Additionally, hair analysis can help identify both victims and perpetrators. Distinctive hair features or even DNA extracted from hair shafts allow forensic experts to make positive identifications. Overall, hair and fiber analysis are essential in many criminal cases, helping to unravel complex situations and ultimately secure convictions with reliable scientific evidence. When it comes to hair analysis, one of the main limitations is that hair can naturally shed or be transferred without any direct contact, which makes it tricky to interpret the results with certainty. Moving on to fiber analysis, a big challenge is that many fibers are common or widely distributed, so they might not be very specific or unique to a particular source. Additionally, analytical methods themselves can face constraints. Sometimes the condition or the amount of the sample isn't ideal, which can limit what we can conclude. Because of all these factors, it's crucial to approach the findings with caution and to support them with other types of forensic evidence whenever possible, ensuring that our conclusions are as accurate and reliable as they can be. Hair and fiber evidence play a crucial role in forensic investigations. These types of evidence are essential because they can connect individuals to specific locations. Through microscopic examination and advanced analytical techniques, forensic experts can reconstruct events and provide valuable insights that support the criminal justice system. Although there are challenges in interpreting this evidence, ongoing advancements ensure that hair and fiber analysis remains a powerful tool in forensic science. Ultimately, this type of evidence helps establish connections and clarify the sequence of events, strengthening the pursuit of justice.